into it. Thank you.
Thank you, TJ. Thank you, Mr. Cairo. Thanks, Kate. So yeah, as TJ was saying, our module, it's the relationship of sabotage analysis to nuclear safety. And this is more of a practical module. So please, if at any point you have a questions or comments, just put it on the chat or raise your hand. So the learning objectives, after completing this module, we should be able to describe the difference between initiating events and initiating events of malicious origin. And in practice, this sometimes gets tough. It's difficult to find those differences. So we'll talk a little bit about that, and I'll use an example, which TJ already mentioned yesterday, to highlight sometimes the difficulty of encountering those differences. We will also describe the relationship between sabotage and accident analysis threshold, as well as explain how accident analysis mitigation impacts sabotage analysis. Can we go to the next slide, Kate, please? One thing that is good to remember is that nuclear safety and nuclear security have a common purpose, and it is the protection of people, society, and the environment. So even though we're coming at the problem from different mindsets, the safety people have a more technical mindset and the security people worried about the protection of the facility, we both want the same thing, and it's to prevent large releases of radioactive material. And to do that, many elements of actions serve to enhance both safety and security at the same time. And this is where I'll go back to what Brad mentioned. It's good to have different experts collaborating in order to come up with threat analysis or DBTs in which we're able to, at the end, protect the facilities. Kate, can we go to the next slide? And safety specialists in close cooperation with security specialists should perform evaluation of consequences of malicious acts in context of what Brad was talking about, the state design basis threat, as well as identifying the minimum complement equipment systems or devices that should be protected. And this is once again where that collaboration really enhanced the process. Me as technical personnel, there's a question, I think, sorry. Should the ones who evaluate the effectiveness of PPS be limited to security operation instead of, wait, I'm reading the one above. Since reactor is shifting in function to accommodate online visitation and experiments with internet reactor laboratory, how do we analyze the ADD? DBT, sorry. I was thinking what was ADD. Yes, in terms of online visitation and experiments with the internet, of course, once we step into the virtual world, the actual threats change, as I think Carolyn was talking about yesterday and Allison the day before. It becomes more of the security in terms of of the information that they have availability. So they might not be able to get into the reactor container and maybe, sabotage an equipment or take a fuel rod. But at the end of the day, if we're not careful on what we're presenting on those online visitation or those experiments, we inadvertently will give information that at the end of the day could be used by adversaries. So my main concern will be that, and I will say that the way to deal with it is to, although it's a virtual world, treat the information the same as if you were in the real world. Meaning, if you're doing virtual experiments, treat them as if the people were there and if they have access. So I hope that works. I hope this answers your question. Sorry, I was still reading. But yeah, personally, I've been involved in giving tours since I was a student of different facilities, and we have done also online tours for a while in some of our facilities. So a lot of what we do is we record the tours, we go through all the facilities, and then we have personnel, security personnel, safety personnel, looking at the videos and making sure that the information that is getting out, it could not be used by adversaries against us. Yes, we have a hand raised. Mr. Carol.
Yes, I want to add my colleague from Yogyakarta, from Mr. Umar, I think. As you know, that Indonesia, during the IAEA General Conference in 2019, I was there as well. So we launched about Internet Reactor Laboratory, particular in Yogyakarta location. So this is one of our efforts to introduce this reactor for particular for the academia, I think. Just for your information. Thank you.
Oh, no, that's very good. But yeah, at the end of the day, we need to protect the information that is out there. And like I said, although we don't have to worry about the physical protection side of things, we do need to think about the information side of things, as well as the knowledge that we are allowing people to have during those visits and during experiments. But I understand, I mean, being in research reactors for a long time, so some of our, like what we want to do as research reactor experimenter or as research reactor facility managers, we want people to use those facilities. So we want to give enough information for them to make assessments of if our facility will be able to handle their experiments. And we also want to talk about the benefits of nuclear power. So yeah, I hope that answered your question. And yeah, thanks, DJ. It should be noted that if HRCs are identical with those defined by the state in relation, oh, sorry, Kate, can you switch slides? I switched in my own, I forgot that we had you. It should be noted that if HRCs are identical with those defined by the states in relation with nuclear safety consideration, the safety analysis should be performed for a facility, could be used as BIA without significant modification. And also we need to remember that almost anything that happens by accident can be made to happen. And this, what we mean in here is that at the end of the day, we need to treat every event that we are analyzing as if it was initiating event of malicious origin. And one of the examples that I like, and I thank TJ for mentioning yesterday, is the stationary low power reactor in Idaho. This was a reactor, a 3 megawatt prototype reactor that was built and operated back in the 60s. And it underwent a nuclear excursion, an accident, and 3 people perished. And there's always been, at the end of the day, nobody really knows if this was an insider that created the accident, or it was an accident because of mechanical malfunctions. But what this tells us is that even though this was years ago, and there's a lot of information about this accident in the internet, and I'm sure a lot of you are aware of it. What this tells us is, at the end of the day, we need to have different experts collaborating when we put this analysis together in order to be able to perform a thorough analysis of the situation. Looking back, everyone thinks, okay, that reactor cannot be an issue right now. But if we go through the history, a lot of the issues with that reactor came from being single-minded. So going back to what Brad was saying is, each one of us, depending on our background, we have a different way of thinking. Meaning, I, as a technical, maybe safety personnel, I want my reactor to be safe, but I also want to be able to perform as many experiments and to produce as many isotopes as I can. So sometimes I become single-minded to that. And if I don't have somebody that with a security expertise in my team, I might neglect some of the parameters that are needed to protect our facility. So it's very important not only to take this as a one-on-one, but also to have a collaboration as a team. And the next slide, please. Thank you, Kate. The results of a safety analysis provide useful input, including target identification and potential radiological consequences, and should be considered during the design of physical protection system. It is important to realize that some events that are incredible from a safety perspective can be made happen by a threat. Therefore, the safety analysis, imitating events, and postulated accidents are a subset of sabotage initiating events and scenarios. And just taking it a little bit back to SL1, one of the things that really caught my attention when I started reading about this accident was that, of course, at that point, there were no security experts. It was different times. But from the reports that are available in the internet, I was able to gather that there was actually not a safety review of the reactor after some modifications were performed, meaning the reactor had a single goal that was be compact and be able to be movable and be able to perform in remote locations, much like the new reactors now, or the reactors that people want to put in remote locations. In this case, that was the single focus. They wanted this to be small. And what they did is they modified the original design, and they took some of the control rods and some of the fuel elements, which caused the center rod had excess reactivity control, meaning that rod could make the reactor critical. Of course, looking back, we think, well, that was a mistake. And every time that I bring this in a nuclear engineering setting, everyone always says that. But at that point, nobody really caught this. Why? Because they were focused on different aspects of the design and different aspects of the plant. Nowadays, with security expertise in our teams, we could probably be able to look at these scenarios from a more wholesome standpoint. So what happened at that point was that the main rod had a mechanical failure, and that mechanical failure made that rod to get stuck. So instead of fixing it, or instead of doing something else with it, the operators started to move it manually, meaning they start to basically bring the reactor to criticality using just their force. So this is where the initiating events of malicious intent or initiating events by accident really get blurry. In that situation, we do not know what happened. If it was a mechanical issue and just an operator that came and tried to move the rod and just use excess force, or if it was an insider that moved that rod in order to create an accident scenario. But at the end of the day, this would have been able to be mitigated if the reactor safety analysis would have been performed, and also nowadays if a security expert is there on the team. Because even if the safety analyst would have been okay with having a rod having that excess reactivity in the middle, probably the security expert would have asked questions that would have prompted a different type of analysis. So at the end of the day, that's what we need to do as security experts and safety experts. Work together, collaborate, and make sure that we assess the reactor facility and the threats from different standpoints, from different expertise. Kate, can we go to the next slide? This was a short presentation, and the summary is an event identified during a design and analysis capable of leading to anticipated operation, incidents, or accident is an initiating event. And the second one is a malicious act, sabotage that upsets operation can lead to an acceptable radiological consequence is an initiated event of malicious origin. And in here, yes, when we are performing our analysis, threat analysis of DBT, there can be a good difference between the two of them, mostly because we are going to have personnel from the security side and personnel from the safety side, and the two of them will have different expertise and will come to the problem with a different mindset. But in practicality, sometimes this is difficult. Once the accident has happened or the event has happened, it's difficult to determine the cause. So we want to think about this as what could be the worst scenario that can happen from a security side, and then run that by the safety side of things and make sure that we have an analysis that takes every aspect of the facility into account. The next thing is mitigation associated with an accident analysis may also mitigate sabotage attack. This is true. Even though when we are at the beginning, when we're performing our safety analysis, we're more worried about the technical side or the things that can go wrong from a technical standpoint. Yes, looking at those things from that side could also avoid sabotage mitigation, and vice versa. Looking at things from a security standpoint would also allow us to come up with different analysis scenarios that will make our facility safer. And this is something that the TJ touched a little bit in terms of what the numbers are, but the establishment of URC and HRC threshold is the regulator's responsibility. And yes, you know, each facility might have a different operational number that they want to do, but at the end of the day, it's the regulator's responsibility, and they do put a lot of time into coming up with these types of numbers. There's another question, sorry. What methods do you recommend to trace the cause of an incident? That's a great question. And at the end of the day, it depends on the incident. If it's a larger incident, like the one that I was describing, they were able to perform a lot of analysis on not only what they thought happened, but also on the equipment. They were lucky enough that they had flux wires, fission wires in the core, and they were able to also use things like clothing from the people that were in there, or the first responders, and they were able to determine what type of fission products and what type of fluxes happen at the time of the excursion. But in general, accident reconstruction, I will say that it's a difficult endeavor. And once again, you will need at this point, you will need your safety specialist and your subject matter experts in terms of if the incident is if an incident is caused by, let's say, fission product release because of a fuel element, regardless of the cause, if it was, caused by a malicious intent or not, you would like to bring your thermal hydraulic experts and your neutronic experts and do analysis and perform experiments to, at the end of the day, figure out what caused that increase in temperature that allow for the fission product release. So it is very accident dependent, and there are quite a bit of techniques that could be used, but at the end of the day, you do need a team that look at the product as a wholesome. So meaning if you're at the end of the day, you want to know first, was this a malicious event? And for that, you will bring your security experts. The next thing is, like, you want to know from the technical side, regardless of how it happened or how it started, how are we going to make sure that the next time this doesn't happen? How can we learn from this? And that becomes more of a reconstruction scenario where a lot of analysis and experiments will have to be performed. I hope that answered your question.
Terima kasih Jorge. Bapak Ibu sekalian, masih ada waktu kurang lebih.
Thank you, Jorge. So, ladies and gentlemen, we have around 10 minutes if you have questions. But I would like to ask first the question.
Yeah, please.
How about in research reactor in United States? So there was an INSAC 2 for 2020 that said interface between safety and security. Now I would like to see what good practice in United States, especially in research reactor, how you can harmonize between safety and security. Is it in the form of organizational structure, which both under one structure, let's say division of nuclear safety and security, like what exists in IAEA. So what is United States experience in the effort to harmonize between safety and security, referring to INSAC 24 year 2010 issued by IAEA? That will be all my question. Jorge, over to you.
Yeah, so of course, in terms of organizations, it always helps that you have that interaction between them. And I'm just going to talk about my personal experience of when I started working in this project in the international nuclear security. And I was brought in because I have my expertise were in research reactors, and I knew the technical side of it and the safety aspect. And I spend a lot of time in facilities. But I quickly realized that I have a mindset of just looking at a problem from maybe a technical side. And when I start working with my colleagues from the security side, such as Kami Byram, and we start coming up with accident scenario and incident scenario, I realized that although we were looking at the same problem, we were looking at the problem from different sides. So in terms of boots on the ground, if you will, of like personnel, I would recommend to have them interact either in a formal setting of you create this type of technical exchange or groups, and also just in kind of like maybe more of an informal setting in which they just get to know each other and they can talk about their jobs in the facilities and what each one of them bring to the table. In terms of going back to management, yeah, I think you're right. Just having those two separate entities interact at a high level is very important as well. But sometimes we neglect the day-to-day, the operations, the people that are doing the work. And I think if those two groups become closer and they work together in projects, at the end of the day, you will have a better product. And that's at least my experience. And I have learned a lot from people like Kami and Brad and other security experts that see the problems from an angle that I really sometimes don't even take into account. But the two of them are looking for the same goal, and is protect the facility and make sure that we are all safe. In the end, the nuclear industry doesn't suffer. So that would be like my personal experience.
Thank you, Jorge.
Yeah.
Thank you so much.
Thank you. Any other questions?
Teman-teman sekalian, masih ada yang ingin bertanya?
Ladies and gentlemen, colleagues, do you have any further questions?
Great.
Oh ya, tadi saya juga ingin komentar tentang.
I also would like to give comments about evaluating the physical protection system. So the nuclear security application in different countries are different. Like how we did it in Indonesia, we evaluate as a team, especially in the Batan. We doing evaluation. We involve the management, because in Batan we have the nuclear security management. So for that we have an audit team that will check the physical protection system in Serpong, Jogja, and Bandung. I just would like to add that for the case in Indonesia, when we evaluating the physical protection system, we involve the management team, the senior management team, because we would like to receive inputs from an independent team for that. And after after the evaluation, we provide recommendation to the management. And by the end of the year, we have a management review to check the follow-up of after the physical protection system evaluation. That's just an information, Jorge. Thank you.
Yeah, thank you, and that's a good point. Having independent groups or independent management groups that look at facilities, it's always very important as well, because they see it from a structure side of things instead of just like from our standpoint. There's one more question, and can you give me an example of a lesson learned of an actual and distinguished safety incident to security sabotage incident? So, I mean, I have a few, but we can go back to, I mean, I'll go back to the SL1 for a minute. And I think the biggest lesson in there was that the single-minded goal of trying to design a reactor that was small and compact override everything else, override security, override the fact that it was not a good design. So at the end of the day, that's what we need to, in terms of safety and sabotage, that's what we need to think about. We need to have a robust system. So even though this was in 1960 and we probably are not, reactors are not designed like that, having robust systems, having systems that could withstand either safety issues or security issues is really the overall lesson learned from a lot of the incidents that have happened through history. And in most cases, once you look at the incident or at the accident, everyone always think, oh, that could have been avoided if we would have done this. And it's easy to think that way. There's another incident that happened a long time ago. It was in a GT reactor in which there was a release of fission products. And at the end of the day, they realized that some of the fuel elements were not fabricated to standard. So once they start reviewing that, they're like, okay, everyone should just look at this fuel element and say, this is not what we need to do. We need to create a robust system where people can say, this fuel element should not be put into the reactor because of this. And if this means we are not going to operate, that's what it means. So at the end of the day, we need to create those systems, not only from the standpoint of security, but also from the management side, that are able to catch issues in our nuclear facilities, either bad designs or fuel elements that are not up to specs, or simply security concerns. So I think the overall lesson learned, like I said, is just having a robust facility in terms of security, safety, and management is what you're looking at. But yeah, there's a lot of examples on accidents, and I think we could teach a class on just that, and it will be really fun. But we don't have time to do all that in this particular setting. But yes.
So Jorge, if I could, from that question, trying to differentiate between a safety incident and a security sabotage incident. I'm sure most of you are familiar with the Tokumura criticality accident in 1999. And for those of you who are not aware, there's a criticality excursion at a fuel cycle facility, a fuel plant in Japan. The operators poured too much enriched material into an unsafe geometric configuration, which caused a critical assembly, a large radiation dose to the operators. I believe there were 2 fatalities with that one, and so being able to tell the difference between accidentally pouring too much material or intentionally pouring too much material into an unapproved container that's a difficult thing to investigate. Now, in this case, since the person who poured it was one of the people who died, we have a pretty good notion that it was strictly accidental, that it was strictly a safety case of violating procedure. But that's an example of having access to material and being able to cause a safety incident that, as Jorge and Brad have pointed out, anything that can be done accidentally can be done intentionally.
Yeah, that's another good example. It's and going back to the SL1, that's kind of the same thing that happened. We are really not sure if it was on purpose or not, but at the end of the day, the accident happened and it had fatal consequences. So if better design or security would have been attached to that system, a different outcome would happen. So yeah, so yeah, there's a few lessons learned, and it's good to go back through history and read them and come up with our own conclusions as well of what can we make a little bit better in our own facilities.
Izin bertanya.
If I can ask question?
Yes,
Mr.
please.
Jorge, this is Pak Teguh. Okay. I would like to ask question with regard to US experience. So this year, the nuclear facility in Serpong, in our place, we have to revise the ADD document. So every 2 years, according to the competent authority mandatory or requirement, the operator must revise the ADD once every 2 years or based on the latest threat. And this year, it happens to be we will review the ADD document that will involve the security personnel outside the site facilities. So what we will review is the local ADD. In Indonesia, we have two types of ADD, the national ADD and the local ADD that is mandatory to be developed by the research reactor. Now, my question is, the United States experience, what is United States experience? Is it only one DBT, one national DBT, or each research reactor are mandatory to develop their own local DBT? So that is my question. Over to you, Jorge.
So just not to give a generic answer, Brad, I think you're better qualified to answer this question in terms of DBT. Is there a single DBT, or is your experience that each facility has their own DBTs in general in the US?
So in general in the United States, DBTs. I had this written down kind of for discussion earlier. There are DBTs are scattered across all of government within the United States. It may not. We have DBTs that affect standard federal facilities. We have DBTs that affect DOE facilities. We have DBTs that affect NRC facilities. NRC, so research reactors in the United States fall under NRC licensing and would then fall under the single NRC DBT, as far as I know. I'm happy to be corrected on that by one of my other colleagues on the line. But I believe that it's all a single NRC DBT for all of it. As far as local threat assessments or local changes to a design basis threat based on local events, that is typically not done unless there is some sort of extenuating circumstance. And typically speaking, it's only done for a short period of time. Somebody asked me in the chat earlier, kind of a pointed question about that. We typically see changes to our physical protection system or physical protection postures on key anniversary dates of past events. If there are demonstrations in an area, if we expect a if we expect a large criminal group to pass through an area, we'll typically raise our alert level or raise our local posture. But it is possible to do it, but there's a single DBT across NRC that's used, and we don't typically have to address individual local considerations.
So Brad, I can add to that as well. So in DOE, we have a single DBT as well. And within that DBT, there's obviously different levels of protection strategy based on the material that you're protecting at your site. And this is a minimum requirements that are located in the DBT. So this is the bare minimum. The site has opportunity to go above and beyond that protection strategy. And that's also based on what Brad was mentioning, the threat assessment, so different threat categories. So if we know that there's a potential of something happening based on intelligence, we can adjust our threat posture based on that. But the DBT is a baseline, a protection strategy for all sites within different levels of categories.
Jeremy.
Yes, sir.
In another word that you mentioned, for the local facility belong to DOE, that's we call it a threat assessment, or because we in the INFISIC 225 we can read about threat assessment and DBT. I think for the facilities like us, like the TAN, to provide DBT is quite challenged. It's difficult, but for the threat assessment, I think we can do it. Thank you.
Yes, Kyril, you are correct. I mean, a threat assessment is the minimum that you need for research reactors. But a DBT is more robust. It's a lot more information, and it takes a lot of effort. In the U.S., we don't change it that often. And we do teach DBT and threat assessment, and I think that's something we could talk about in the future, Mr. Kyril, a future course. We can talk with Taylor later on when we have our meetings, but I think that's something we can propose in the future to expand on this topic.
Okay, thank you.
Thank you.
Thank you, TJ. Go ahead, TJ, for the next model.
Yes, thank you, Mr. Carroll. The next module will be module number 5, and I'll be giving that back to Brad Taylor for him to give the presentation. And this will be on the process for developing the physical protection system design. So, Kate, if you would like to go ahead and pull those slides up, then I'll be glad to hand it over to Brad.
Thanks, TJ. While Kate's pulling those up, I'd like to say a big thank you to everyone who's asking questions. It's very nice to see all of the questions that are coming through. It makes for a much better, more interactive session. I hate sometimes just looking at these slides, thinking I'm reading slides to an empty audience. So again, I really appreciate the questions, the feedback. It makes some of this online delivery much more personal. So again, I appreciate it.